Okay, so all we have left for blood and lymphatic infections is the protozoa diseases, and we're just actually covering malaria. Okay. Why do I not have my little slideshow button? There we go. Who knows? Okay, so malaria is caused by several Plasmodium. They're a protozoa. We're going to look at the life cycle of a particular species, which is vivax. And then we're going to discuss why malaria has been so difficult to control. So some background on malaria itself. We did have it here at one point in the United States. The good news is we no longer have it here in the United States, but there is always the potential that we could. So people who get it experience flu-like symptoms, includes fever, headache, pain in the joints and muscles. Generally, this begins 2 weeks post-infection, and again, this is going to vary depending on which species of the Plasmodium you get infected with. But the transmission is through the bite of an infected mosquito, and so we certainly have mosquitoes here in Louisiana, and that's why at one time we did have malaria. But the good news is that the wild animal population that harbors it, we don't have a large amount of. So the mosquitoes aren't picking it up and transmitting the protozoan to us. Because there's a life cycle that we'll go over in a moment related, symptoms tend to go with the cycle of the Plasmodium, of this protozoa, its life cycle in our body. So people experience what's referred to as the cold phase. These are abruptly feel cold and develop shaking. The hot phase is after the cold phase, and this is when they spike the temperatures, when they have fever. The wet phase follows the hot, right? Because once you get really hot, you sweat, right? And you get wet. And you have the drenching sweats that occur. And then the cycle starts all over again. So quite miserable. The cause of an agent, as I said, is a Plasmodium, but there are 4 different species that cause this infection: Vivax, Falciparum, Melitini, and Ovale. So this parasite, this protozoan, gets injected into us via the bite of a mosquito, and then from our bloodstream it's carried to our liver, and it affects cells of the liver. And then thousands of offspring from that growth in the liver bust out to produce an infection in our erythrocytes, our red blood cells. So let's look at that. So the sporocytes are what come from the bite of the mosquito, right? And they inject this into our bloodstream. Then they travel to the liver, right, where they infect liver cells and produce the metrocytes. The metrocytes that bust out of the liver cells then infect our red blood cells and become the trophocyte, then the syncytoid, which that one can break into more metrocytes. So this can continue this cycle in the red blood cells, or they can become gamocytes. And what gamocytes are, male and female, right? Sexual cells. Those, when they're picked up by the mosquito, the gametes from our blood, so when they bite somebody who has malaria and they pick up those gametes do sexual reproduction, right? They become fertilized, form the zygote, and produce the oocytes, which are the sporocytes that infect their salivary glands, so that when they bite the next person, they're transmitting the sporocytes into that person, and the cycle starts all over again, right? over and over again. So in this diagram, they're showing you that how the cycle can go, right? How they can bust out and then reinfect red blood cells, go through that process, produce more, right, that can go and infect. Others can produce the gametes, right? And that's why it's showing male and female cells. Those are picked up by the mosquito, and those are mate inside the mosquito and then form the sporozytes that start the cycle all over again. The sporozytes actually have to infect the liver cells, right, to produce the metrozytes, which are the ones that can reproduce in the red blood cells. What did I want to say? So depending on, and I don't have time frames on this one, depending on the species, there's a certain amount of time it takes for them to go through the process of going from a sporozyte to a metrozyte in the liver cells. And when they multiply, how long it takes for them to multiply within the red blood cells. And those coincide with those phases of the fever and the cold and the sweats that people experience. And that time frame is dependent on the species in which they're infected with. I'm not gonna have you guys memorize to that detail, right? But understand that there are these different forms within the life cycle, right? It's the sporozytes that you get from the mosquito that go to your liver that produce the metrozytes, which infect your red blood cells, that also can produce the gametes that are picked up by the mosquito where reproduction actually happens, right? Sexual reproduction. And then they produce the sporozytes and the cycle starts all over again. So characteristic feature of this is the recurrent bouts of fever followed by times of wetness. And as I said, this coincides with the cycle within the red blood cells, right? How long it takes. They pretty much infect the red blood cells and all bust out of the red blood cells around the same time. And so you get this destruction, large number of destruction of red blood cells. Remember, no, we didn't talk about this in this class, did we? What happens when you have destruction of your red blood cells? What pigment builds up in your blood? Anyone know? It makes you yellow. Bilirubin causes what we refer to as jaundice, right? Which is why yellow fever gets the name it gets, right? Because of the destruction of liver cells and red blood cells that'll cause the jaundice condition. So as I said, each species has different incubation periods, degrees of severity, preferred host age and range even. The spleen will enlarge, and again, this is because your spleen is what's going to help deal with these red blood cells that are getting destroyed by the parasite. And because of that, sometimes the spleen will even rupture, which is a horrible side effect that can happen with this disease. The parasites, because they're growing inside, right, and destroying red blood cells, it can lead to severe anemia. And converting our iron from the hemoglobin into a non-usable form. So then individuals have to take iron supplements to replace the iron they're losing. It stimulates the immune system, right? And it can even overwork the immune system to the point where it's so busy with the malaria, it can't help defend against other types of infections, right? So that people become immunodeficient. Once common in both temperate and tropical areas, now it's a dominant disease of warm climate. And we'll look at the maps for this in a moment. It was eliminated from the continental U.S. in the 1940s, thank goodness. The mosquito that is the biological vector, because again, the reproduction happens there, is the Anopheles. And we do have that mosquito here. But as I said, we don't have the wild animal population harboring the protozoa, or people for that matter. The infected mosquito and humans constitute the reservoir. So we don't have human infection here in the United States. Not endemic. Most people who have the infection is because they've traveled. So transmission is via mosquitoes, blood transfusions even, right? Because it can be in the blood, and sharing of syringes. So no endemic malaria, as you can see, in North America in general, as well as Europe and most of Asia. China, India, no, I shouldn't say Asia, USSR. That's what I was thinking of. It's a serious problem, right, in the warmer climates. So Africa, South America, India, China, the islands. And this map shows you the different drugs that are used. So you'll see that we have a large area of the world, the purple, right, that are resistant to chloroquine, and others that are resistant to another drug, mefloquine, in some areas that are still sensitive. And, you know, this map is kind of misleading too, because it's like, well, which species, right? Because there's 4 different species. They don't even take into account that, but what drugs are working where. So it might be related to specific species even. Treatment is complicated because of the resistance that we're seeing as well. And the chloroquine is effective against the erythrocyte stage, so only against the metrocytes, right, that are infecting the red blood cells. It can't cure the liver infection. Where these other 2 drugs generally are effective against the outside the erythrocyte stage and certain species, and again, notice only certain species, gametes. So that brings us back to one of our original objectives, is why has it been so difficult to control? Because we have that difference in the life cycle, right? And we only have certain drugs that can affect different parts of the life cycle. And as the map points out, some of them have developed resistance. So you've got that problem, right? We don't have really an effective treatment. Even worse, we've developed resistance. And then we're also dealing with a vector-borne disease, right? We're dealing with trying to control mosquitoes. So we have multiple things working against us here on this one. All right, so that's the end of everything, actually, just about.
Do we have like an overall, like a study guide almost for the final?